Hello there, and welcome. I'm so glad you've arrived. Maybe your day has been busy, full of noise and motion, or maybe you're simply the kind of soul who drifts off best with something vast and quiet to think about. However you found your way here, this moment is yours now. Slow, silent, and filled with stars. You don't have to do anything but rest. Let your breathing soften. Let your eyes grow heavy. Let the rhythm of the night carry you. Tonight, we won't be chasing answers. We'll be stargazing with our thoughts, floating gently through a sky not just full of stars, but full of wonder, deep, glimmering, unhurried wonder. The kind that stretches across light years and lingers in your chest like a song you almost remember. Above us, the night sky is not empty. It is alive with secrets, cold fires, ancient lights, invisible winds, and glowing ghosts of long-dead stars. And in this quiet space, we'll wander through 100 astonishing truths, not just about stars and planets, but about the cosmos itself, and how strange and beautiful it really is. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. When you look up at the night sky, you are not seeing now, you are seeing then. A long, layered collage of moments from the past, all arriving in the same instant, filtered through darkness and distance and time. Every star, every point of light, is a memory in motion, a message that's been traveling toward you across the vastness of space. Some of those messages are recent, cosmically speaking. Others began their journey long before your ancestors took their first breath. The night sky is not a live broadcast. It's a delayed transmission, a silent echo from the deep past. Take a moment and let that settle in. The starlight touching your eyes tonight may have begun its journey 100 years ago, or 1,000, or more. For some stars, the journey is so long that they might not even exist anymore. They may have burned out, exploded, or collapsed into silence centuries ago. But you still see them, not as they are, but as they were. Their light is only now arriving, slipping through your atmosphere like a whisper. To see the night sky is to look through a lens built from time itself. Even the closest star systems are distant enough that their light takes years to reach us. Sirius, the brightest star in the night sky, lies just over 8 light-years away. That means the light you see tonight left Sirius in 2017. It's recent enough that you might remember the day, something you ate, someone you missed. You lived through the moment that light began its journey, and now, years later, it arrives gently in your gaze. But that's one of the nearby ones. Move your eyes toward Betelgeuse, the reddish star in Orion's shoulder, and you're looking at light that's been traveling for over 600 years. The world was a different place when it left. Empires were rising and falling. Sailors were still guessing at the edges of the map. Now, that ancient glow drifts into your eye, as if no time has passed at all. What makes it more surreal is that not all of Orion is the same age. You may see it as a single pattern, a celestial figure etched cleanly into the sky, but each star belongs to its own timeline. They are nowhere near each other in space, and certainly not in time. Rigel, glowing blue-white at Orion's foot, is nearly 900 light-years away. Bellatrix, near the shoulder, is only about 250. The 3 stars of Orion's belt, each from a different distance, each arriving after its own silent journey. You're not seeing a portrait. You're seeing a stitched mosaic of centuries, a moment made from many. This delay isn't a flaw. It's the nature of light, even though it moves incredibly fast, around 300,000 kilometers every second. Space is just too big, too stretched. Distances are measured in time because that's the only be, and the way they make sense. A light year isn't a unit of space, it's a unit of time woven into motion. It tells us how far light can travel in a year, and when you look up, you see those years written in the stars. You're not just looking at where they are, You're looking at when they were, and that means the sky is a map of vanished moments, a slow-moving slideshow of old fires and fading suns. Some of them still burn, sending more light after the first. Others are long gone, leaving behind only their echo. Their glow keeps traveling, long after the source has gone dark. We can't see the silence that follows. We only see the message, the final gleam before the curtain closed. You may have seen a star die centuries after its last breath. There's something deeply gentle about that, a kind of cosmic grace, that the universe is arranged in such a way that light lingers, that nothing, not even the end of a star, happens all at once. Even destruction, even collapse, arrives with delay. You can imagine a supernova flaring somewhere far away in a galaxy you can't quite see. Its shock waves racing outward, its core turning inward, the light flying faster than anything else, trying to carry the news. And still, we wait. Perhaps that light is already on its way to us. Perhaps someone, long after us, will look up and see it arrive. To observe the sky is to wait. Astronomers call it looking into look-back time. The farther away something is, the deeper into the past we are peering. Some of the faintest galaxies captured by our telescopes are over 13 billion light-years away. That means we are seeing them as they were 13 billion years ago, not long after the universe itself began. No photograph, no painting, no story has preserved a moment as ancient as that, just the light, quietly crossing the emptiness, unbent by time, until it touches a mirror, a lens, an eye. Even the colors tell a story. As light travels, it stretches. The more distance it crosses, the redder it becomes. A phenomenon called redshift. We use it to tell how fast something is moving away, how far it has gone. A star's hue is a breadcrumb on the path of its journey. The past is not silent. It glows softly in color-coded threads. There's a comfort in knowing this, that light doesn't just disappear, that it carries on, drifting through space until it lands, that when you lie back on a clear night, you're not just watching stars twinkle, you're catching stories mid-arrival. You're watching an ancient drama unfold in slow motion, across a stage too big to ever see all at once. You are the last stop for a photon that has traveled across centuries, maybe millennia, only to end its voyage in your vision. And so, when you look at the night sky, remember this. You're not just looking up, you're looking back. The stars are not just there, they were, and their light, still coming, still arriving, still glowing. It has found you. The night sky feels eternal, still, as if the stars were nailed into place long ago, frozen in the patterns our ancestors once traced with fire-lit fingers. We look up and see permanence. Orion still hunting, the Big Dipper still pouring, Polaris still pointing north. And yet, all of it is moving. Not in a way your eyes can catch, but quietly, constantly, with the patience of gravity and time. The stars are adrift. Every light above you is in motion, dancing slowly through a universe too vast for stillness. If you could press your thumb to the sky and leave it there for 10,000 years, you'd notice it. The constellations wouldn't look the same. Familiar shapes would bend and fray at the edges. Stars would drift apart. Some might vanish below the horizon. Others would rise where none existed before. What we see now is only a moment in a long unfolding, a temporary snapshot in a sky that never stops shifting. Earth spins beneath it all, fast and rhythmic. But even the axis of that spin is not fixed. It wobbles gently, like a top that's been spinning for too long. This motion is called precession. Over a period of about 26,000 years, Earth's axis slowly traces a circle in the sky. It's not something we feel, but over millennia, it changes everything. The North Star today, Polaris, hasn't always held that role. In ancient Egypt, it was a different star entirely. And in another 12,000 years or so, the title will pass again to Vega, bright and blue and waiting its turn. That means the compass in the sky, the one sailors once trusted, the one explorers followed, is not permanent either. Polaris may feel like the anchor of the northern sky, but even anchors drift when set in a sea made of stars. What we call the North Star is a temporary arrangement. Like so much in space, it just happens to be true right now. The constellations, too, are more fragile than they appear. Take the ones you know best. The hunter, the lion, the swan. They've been stitched into stories for thousands of years, carved into stone, whispered under open skies. But those stories are shaped by alignment, not proximity. The stars that form Orion, for example, are not clustered together in space. Some are hundreds of light years apart. They only appear close because of our point of view, like a city skyline seen from a distance. Move sideways and the shape collapses. And that's exactly what time does. Over thousands of years, the stars move. Their orbits carry them across the galaxy at different speeds, in different directions, on paths tilted and curved by invisible forces. It's not chaos, it's just motion. And slowly, the figures we've drawn from those stars begin to dissolve. The belt of Orion stretches. The Big Dipper's handle curls. Cassiopeia leans farther back. Not dramatically, not suddenly, but undeniably. You won't notice it in your lifetime, or in 100. But if you could fast forward the night sky, let centuries blur past in seconds, the change would be impossible to miss. The stars would slide like slow drops on glass. Shapes would melt, new ones would form. The entire sky would feel like a living thing, breathing and shifting in silence. Even the zodiac signs, which once tracked the sun's path across the sky, have shifted. Because of precession, the sun no longer passes through the same constellations at the same times of year. The sky has slipped a little. It's subtle, but it's real. The stars are not where they were. The night sky of Babylon, of Stonehenge, of the early pyramids. It is not the same sky you see now. And it won't be the one your descendants see either. That's the strange beauty of it. We tend to think of the heavens as fixed, the opposite of our changing world. But in truth, the sky is just as alive. It simply moves to a slower rhythm, a rhythm so slow that it lulls us into thinking it stands still. But every star is on a path. Every star is going somewhere, and we are too. Our solar system is orbiting the center of the Milky Way, carried through space like a leaf in a vast current. It takes about 225 million years to make one full lap. That means the last time Earth was in this part of the galaxy, the dinosaurs were just beginning to rise. In all of Earth's history, we've only made that journey a handful of times. And all the while, the stars have been shifting beside us, ahead of us, behind us, each one tracing its own long spiral through the dark. Even our own sun moves through the galaxy. It drags the planets behind it, including Earth, like beads on a string. And as we travel, we pass through clouds of interstellar dust, through spiral arms filled with newborn stars, through zones of calm and chaos alike. The sky is not a ceiling, it's a river, and we are drifting in its current. Sometimes, you can see hints of this motion even now. A bright star that seems a little out of place, a meteoroid streaking across the sky, not part of any constellation. The slow precession of the planets as they glide along the ecliptic, wandering in and out of view. If you watch carefully over nights and seasons, you begin to feel it. That sense that nothing above you is truly still. And yet, for all this motion, the sky feels peaceful. That may be the most magical part. It moves without hurrying. It shifts without strain. It changes with no need for attention or applause. Just steady transformation. written across millennia. When you next look up and trace the outline of a familiar shape, remember that it is only temporarily familiar. The hunter in the sky will eventually lower his bow. The dipper will spill, the dragon will unravel. But new patterns will emerge, new shapes, new stories. The sky changes, just not at the speed of a breath, or a season, or even a lifetime. It changes like a glacier melts, like mountains grow, like time dreams. And even if you can't see the stars move, they are moving, quietly. Always. So are we. At first glance, the night sky seems drained of color. A soft silver hush spread across the dark, scattered with what looks like pinpricks of white light. Stars shimmer, they sparkle, but they do not seem to burn in hues. Most people would say the stars are white, maybe slightly golden, but that's only because our eyes weren't built for the truth. The real sky is far more vibrant than we're able to perceive. Color is there, bold and radiant, hidden just beneath the limits of our night vision, waiting to be noticed. In low light, your eyes shift how they see. The cells responsible for color, the cones, step back, and the rods, which are better at detecting motion and dim light, take over. This switch helps you see more stars, but at the cost of color. It's called the Purkinje effect. Reds fade first, blues linger a little longer. But mostly, the world turns to shades of gray, like a photograph left too long in moonlight. This is why the stars seem to lose their fire. They're still glowing in brilliant hues, but we only see the ghost of that light. Look a little closer, though, and hints begin to show. The brightest stars, the ones that push through the veil of night vision, sometimes reveal a little of themselves. Sirius, low in the sky, flickers like a prism, its light bending through the atmosphere and splitting into blues and greens, even hints of violet. Betelgeuse burns with a warm, ruddy glow, like the heart of a coal just before it fades. Rigel glows cold and blue, piercing and crisp like ice under starlight. But even then, it's subtle, a whisper of color, a suggestion, never the full spectrum. The truth is, stars come in a rainbow of temperatures. The hottest ones, burning at tens of thousands of degrees, shine in deep blue and ultraviolet. These are massive, short-lived giants, churning through their lives with violent energy. Cooler stars, smaller and slower, glow in oranges and reds, their fires calm and enduring. Our sun, halfway between, glows yellow-white, though if you saw it from space, without the distortion of atmosphere, it would appear closer to pure white. In this way, stars are not just lights, they are thermometers, spectacles of fusion, whose very color tells a story of heat and age and mass. Some stars don't even stay still within their color. They pulse, their brightness rising and falling in gentle rhythm. These are variable stars, and many of them change in hue as they breathe. As they swell, their outer layers cool, and they shift toward red. As they contract, they grow hotter, and the light swings back toward blue. It's a slow flicker, like a lantern swinging in a breeze. Some stars pulse every few hours. Others take days, or weeks, or months. Their rhythm becomes a clock, and their color a changing face, always in motion, never quite the same. With binoculars, the transformation becomes undeniable. A sky that once seemed pale and uniform begins to bloom. Albireo, in the constellation Cygnus, is revealed to be two stars locked in a slow orbit. One golden, one sapphire. Antares flares red and swollen, a dying giant nearing the end of its life. Capella flashes warm and rich, almost like honey, while Vega burns white-blue, sharp as a blade. Through magnification, the sky becomes a painting, not a static one, but a living canvas of thermal fire. In fact, even without optics, there are moments when the atmosphere itself plays with color. When stars hang low on the horizon, their light is forced to pass through more air, and the layers of the atmosphere bend it like glass. The result is scintillation, a trembling flicker that makes some stars appear to twinkle in shifting colors. It's most noticeable on cold, still nights, when the sky is steady and your breath rises like smoke. To some, it feels like magic. To others, a hint of chaos in an otherwise ordered universe. But the colors are more than beautiful. They're clues. Astronomers use them to read the temperature, composition, and movement of stars. They break the starlight into a spectrum, the way a prism splits sunlight, and study the fine lines etched within. These are absorption lines and signatures left by the elements inside the star. Hydrogen, helium, calcium, iron, each leaves its mark. From a beam of light, they can tell how hot the star is, how fast it's spinning, even whether it's moving toward us or away. The color of a star is not just its hue, it is its identity. And yet, to the naked eye, all of this richness is softened, distilled into something quieter, simpler. We are left with the impression of light, without its depth. But maybe that's part of the sky's kindness, that it doesn't demand understanding to be appreciated. Even if we can't see the colors clearly, they're still there, glowing patiently, waiting to be noticed. The night doesn't need to shout its secrets. It simply offers them, gently, for anyone who wants to look a little closer. So the next time you lie beneath the stars, try to see them not just as white lights scattered across the dark, but as glowing embers of different fires. Some burn fast and bright in sapphire heat. Others flicker gently, orange and slow, nearing their end. Some pulse like sleeping hearts. Some shimmer with colors bent by the breath of the earth. They are all part of a spectrum hidden just below the threshold of our senses. And if you bring binoculars, or a telescope, or simply a little more time, the night sky may reveal itself in ways you've never seen before. Not brighter, just deeper, more honest, full of a color that was always there, just waiting for you to find it. The sky has always been a place we associate with beginnings, a new dawn, a guiding star, a celestial birth. But quietly, almost imperceptibly, it is also filled with endings, with remains, with monuments of light built by things that no longer live. When you look up at the stars, you are not just seeing brilliance. You are seeing decay suspended in motion, a kind of elegant ruin glowing across vast distances. Death in the sky is not empty or cold. It is radiant, expansive, and strangely beautiful. Some stars die gently, others go out in fire. When a small or medium-sized star like our sun reaches the end of its life, it begins to unravel. Its outer layers drift away, pushed by pulses of energy and change, shedding themselves into the dark. What's left behind is a white dwarf, a dense, glowing ember no larger than Earth, but with the mass of a star. It doesn't shine from fire or fusion anymore. It shines because it is still hot, still cooling from the inside out. It is, quite literally, the ghost of a star. Many of the faint, steady points of light you see above are not living stars at all, but these quiet remnants, these stellar corpses, they do not grow. They do not burn. They only fade, for billions of years, into silence. Around some of them, if the timing is right and the conditions align, the material they once shed forms a glowing shell, a planetary nebula. The name is misleading. They have nothing to do with planets. But the early astronomers who saw them through their primitive lenses thought they resembled distant, pale worlds. In truth, they are more like halos, expanding clouds of gas and dust, lit from within by the dying heart at their center. The cat's eye, the helix, the ring. They look like eyes because they are echoes of sight, fading gazes turned outward forever. And then there are the violent endings, the ones that arrive in an instant. When massive stars die, they don't shed. They collapse. Their cores implode under their own weight, triggering a supernova, a flash brighter than billions of suns. For a few brief moments, the star outshines its entire galaxy, and then it disappears, leaving behind a remnant. These are not neat shells. These are shrapnel, torn clouds of material flung across light years, tangled filaments of gas and magnetism, slowly expanding like ripples from a forgotten detonation. These remnants glow because they are still hot, still charged by shock waves and radiation. They are not quiet. They hiss in radio waves and X-rays and ultraviolet, broadcasting their aftermath across the dark. The Crab Nebula is one such echo. It began as a star, somewhere around 6,500 light-years away. In July of the year 1054, its death arrived on Earth in the form of a light so bright it could be seen in daylight. Chinese astronomers recorded it. So did skywatchers in Japan, the Middle East, and likely the Americas. It lingered for weeks, and then it faded, returning to invisibility. What remains now is a twisted cloud of luminous filaments, pink and blue and violet, spread across space like a burn. In its heart lies a neutron star, spinning 30 times per second, pulsing with radio waves like the ticking of a clock no one wound. The light you see from the Crab Nebula tonight is a recording of that violence, still playing. To see it through a blind telescope is to see a fossil of flame. It is not the explosion itself, but its footprint, a glow carved into the darkness by absence. And yet, the sky does not feel grim. There is no mourning written into the constellations. Death in space is not a void. It's a transformation. Matter doesn't vanish. It spreads. The gases from old stars become clouds. Those clouds collapse and form new stars. Some of the calcium in your bones, the iron in your blood, was made in a supernova. You are not just stardust in a poetic sense. You are built from remnants. You are assembled from cosmic debris that once lived and burned and ended. In this way, the night sky is not just a gallery of light, but a gallery of memory, of change, of persistence. There is no line between a star being alive and a star being gone. The death of a star is not its end, just a change in what kind of story it tells. Some whisper, some shout, some leave behind patterns you can still trace, even if the original source is long cold. We are surrounded by echoes, and we call them beautiful, because they are. The Veil Nebula, torn and delicate. The Ghost of Jupiter, round and pale blue. The Pulsar Wind Nebulae, throbbing with invisible energy. There is no symmetry to these structures. They don't follow the clean lines of geometry. They expand, ripple, fray. They look like smoke, like lace, like breath caught in the cold, and they're still changing. Nebulae stretch outward with each passing year. The filaments drift apart. The shock waves lose energy. Slowly, the sky forgets the shape of what it once was, but not completely, not yet. For now, these shapes remain visible, glowing gently in the telescopes of patient watchers, markers of a sky that remembers its dead. If you could see in every wavelength, not just the narrow band of visible light, the night would look like a graveyard of fire. X-rays would reveal skeletal structures of exploded stars. Infrared would trace the warmth of clouds still, cooling. Radio waves would sketch out the spinning corpses of collapsed cores. All of it alive in some form. All of it moving, decaying, radiating. You are surrounded by endings, and yet they shine, not with despair, but with clarity. Stars do not go quietly. They blaze, they scatter, and they leave behind color and motion and dust that will one day become something new. So when you look up tonight, remember that many of the lights you see are not just burning, they are remembering. They are retelling stories of collapse. And somehow, they are beautiful because of it. Not despite the ending, but because of it. You are not looking at stars. You are looking at ghosts made of light. The moon feels like it has always been there. Quiet, silver, watching. It rises and sets with the grace of ritual, pulling at oceans, haunting poets, slipping behind clouds with the elegance of something that knows it will always return. But even the moon, that ancient companion carved into myth and memory, is not truly still. It is moving, slowly, invisibly, and away from us. Each year, it drifts about 3.8 centimeters farther into space, just a little more distance, just enough to notice over eons. The tether isn't broken, but it is loosening, thread by delicate thread. This means the moon used to be closer, much closer, when it first formed, likely from the debris of a colossal impact between Earth and a Mars-sized body. It would have hung in the sky like a titan, 3 or 4 times larger than it appears now. Imagine looking up and seeing that, not a coin-sized light, but a colossal orb, so close you might feel it breathing. It would have ruled the sky, casting shadows sharper than the sun's, turning night into something luminous and strange. Back then, tides were fiercer, the days were shorter, and Earth's spin was quicker. The moon was close, and its presence reshaped the world. Even now, its gravity tugs at the oceans, pulling water into long, slow breaths we call tides. Without the moon, those rhythms would be smaller, flatter, quieter. Coastal life might never have emerged. The interplay between land and sea, the pushing and pulling of nutrients, the gentle exposure of tide pools, all of it was sculpted by the moon's steady influence. Its presence is written into the code of life. It's not just a companion in the sky. It's part of the story of how Earth became Earth. Ancient people watched the moon with reverence. They tracked its phases, celebrated its cycles, etched its eclipses into stone and clay. In Mesopotamia, astronomers carved records of lunar eclipses into tablets thousands of years ago, noting the way Earth's shadow darkened the moon's face. These were not just observations. They were timekeepers, omens, clocks made of darkness, and they give us something remarkable, a way to measure the moon's drift across time. Because the timing of eclipses has changed, the moon has moved, and those ancient records prove it. Today, the moon takes about 27.3 days to orbit the Earth. Its dance is locked with ours, so we always see the same face, the same pale terrain of craters and plains and ghostly seas. But its distance changes everything. Right now, the moon is just the right size and just the right distance to perfectly cover the sun during a total solar eclipse. It's one of the great cosmic coincidences. The sun is 400 times larger than the moon, but also 400 times farther away. So when they align, the fit is perfect. For a few breathless minutes, day turns to dusk, and the sun becomes a ring of fire. But that won't last forever. As the moon continues to drift away, that perfect alignment will fade. Each year, it recedes a little more, and in a few 100 million years, total solar eclipses will cease to exist. The moon will still cross in front of the sun, but it won't fully cover it. There will always be a ring of light, a reminder of what used to be, a memory lingering in the sky. The eclipse will become partial, forever. We live in a rare sliver of time, a moment when the moon is just far enough to make solar eclipses a phenomenon, but close enough to still command the tides. The moon will always orbit Earth, but the shape of its influence is changing, has always been changing. The Earth's rotation is slowing too, just a little. Days are growing longer. Ancient coral fossils record growth patterns tied to sunlight, and from them, scientists can tell that a day hundreds of millions of years ago lasted only about 22 hours. The moon's pull is part of what's making Earth spin more slowly. It's not just moving away, it's changing time itself. There is something deeply human about the moon. It feels close, even though it's a 250,000 miles away. We've walked on it, left footprints and flags and machines. We've studied it through telescopes, written songs for it, told told stories where it turns to wolves or controls madness or cradles lovers in its glow. It's both a scientific object and a mythic presence. A rock, yes, but also a mirror, a symbol, a witness. And now we know it's leaving. Not fast, not dramatically, but undeniably. Like a dear friend slipping into the distance, waving as they go, certain they'll never disappear, but knowing, too, that things won't stay the same. Even as it moves away, the moon continues to shape us. It marks our calendars. It sculpts our sleep. It rises full and round, calling out something primal in us. Its gravitational pull reaches into our oceans, our tectonics, maybe even our biology. It is present in ways we don't always see, quiet, but never absent. And one day, when humans look back from a more distant future, they will marvel that we lived in this age. An age when the moon could still perfectly blot out the sun, when a sky could go dark in midday, and stars could blink through a solar curtain drawn tight by lunar hands. The moon is not falling in the way that things crash or crumble. It's falling outward, caught in a slow spiral. Gravity and inertia trading secrets, endlessly. Every year, a little more space opens between us, a tiny step, a celestial exhale. But it's enough to reshape the planet, to change how we see the sun, to remind us that nothing in the universe is truly fixed. Look up tonight, and there it will be, still glowing, still near, still casting its light across the water and through the trees. But now you know, it's drifting, almost imperceptibly, almost kindly, and in that motion is a kind of grace. The moon is not fleeing, it is dancing, and the dance goes on, right now, no matter how still you are, no matter how quiet the room, how soft your breath, how deeply your body settles into sleep, you are moving, faster than you can feel, faster than your senses can comprehend. It doesn't feel like motion, but it is. You are riding a planet that spins, orbits, and races through space, caught in a chain of invisible motion that never stops, never slows, never asks for permission. At the equator, Earth turns at over 1,600 kilometers per hour. If you stood there, you'd be hurtling eastward, your feet on solid ground, but your whole body spinning with it. Closer to the poles, that speed lessens, but the motion remains. You are always turning, even when you sleep. You don't feel it because everything around you turns with you. The trees, the houses, the oceans, the clouds. You are part of the spin, woven into it. To feel it, you'd have to look beyond Earth itself. And if the spin wasn't enough, Earth also moves in orbit around the sun, an immense ellipse that stretches nearly 940 million kilometers. We complete one lap every 365 and a quarter days. That means, right now, you are traveling through space at roughly 107,000 kilometers per hour, around and around, once each year, with no pause. It doesn't feel like flight. It doesn't tear at your hair or tug at your breath, but the speed is there, vast and constant. It's what turns seasons, shifts, constellations, draws shadows in new directions each day, and you are part of it. But the motion doesn't stop there. The sun itself is moving, dragging the entire solar system along in a wide, spiraling orbit around the center of the Milky Way. At this scale, things slow down only in the telling. The reality is even faster. Our solar system races around the galactic center at approximately 828,000 kilometers per hour. It takes more than 200 million years to complete a single orbit. In all of human history, in every story ever told, every war, every poem, every kiss, the sun hasn't made it even halfway around the galaxy. We are newborns in the great spiral, and the galaxy too is moving, falling toward Andromeda, floating through the fabric of space shaped by gravity and dark matter nudged by things we cannot see and may never fully understand. Everything, from the smallest dust to the largest clusters of galaxies, is in motion. Nothing is anchored. Nothing is still. You don't feel it, because motion, when shared perfectly, becomes invisible. You are not being dragged. You are floating in a current, one that started before you were born and will continue long after you're gone. The stars above you, sharp and steady, seem fixed, but they too are in motion. We call them fixed stars because they shift so slowly it takes centuries to notice. But they're drifting through space, each one on its own trajectory, like fish in a cosmic stream. The night sky is not a ceiling, it is a river, and you are moving through it. Even now, as you lie still, you are part of this movement. Your heart may be quiet, your breath gentle, but your body is flying at speeds no vehicle on Earth could match. Every moment, you are carried farther from where you were a second ago, and yet everything feels still. This is one of the strange gifts of space, that it holds you in motion without disturbance, like riding in the eye of a storm you'll never see. Sometimes, you can feel hints of this motion in the sky, the arc of the sun across the day, the slow drift of stars from east to west, the way the constellations change from season to season. These aren't just calendar marks, they are the shadows of our movement through space. A sundial doesn't just measure hours, it whispers of rotation. A star chart doesn't just guide you, it tells you that you are in orbit, spinning and circling in patterns too vast for footsteps. We often imagine space as a place, somewhere we go, somewhere, out there. But you're already in it. You've never left. You were born into motion. Every breath you've taken has been on a moving world, in a moving system, inside a moving galaxy. The sky isn't above you. It's around you, behind you, in front of you. There is no center. There is only flow. And it's not chaotic. It's graceful, predictable, even. The paths of planets, the arc of moons, the orbits of stars, they follow rules written into the fabric of space. Gravity is not a force pulling you down. It's the shape space takes when mass is present. It curves, and we follow. That's why you don't feel yourself moving. You are riding a curve so vast and smooth that your body reads it as rest. It's strange to think that the stars you see are not just ancient in time, but also displaced in space. The light reaching your eyes now left those stars long ago, and the stars themselves have moved since then. What you're seeing is a memory of their position. The sky is a mosaic of times and places, layered into one moment of stillness that only seems still. You are part of a dance you cannot feel. You are inside a choreography older than language, and though you may never sense the speed, never feel the tilt or sway or spiral, you are always moving. It is not a flaw in your perception. It is a gift, a quiet mercy, because if you could feel it all, the spin, the orbit, the galactic drift, you might never rest. But now, knowing it, you can lie back and let it carry you. You are cradled by motion, cradled by speed so immense it becomes silence. There is nothing you need to do. You are already traveling, already part of the rhythm, already riding the hidden currents of a sky that only pretends to stand still. When you look up at the night sky, it seems so quiet, still, even, just a scattering of lights on a black canvas, calm and distant, like the universe has hushed itself for your gaze. But what you see is only the gentlest whisper of what's actually there. The visible stars, the constellations, the moon, and the Milky Way. All of it is the faintest slice of something much larger, more chaotic, more vibrant. The night sky is not silent, and it is not dark. It is full of storms and signals and glowing tides that your eyes can't touch. All around you, the universe is pulsing with radiation, not the kind that burns or wounds, but the kind that carries stories, information written in wavelengths that bypass your senses entirely. Infrared light, too long for your eyes to register, flows from cool stars and dust clouds, painting the night in heat. Ultraviolet light, too short and sharp, streams from young stars and exploding suns. X-rays blaze from the torn edges of black holes. Gamma rays burst from the depths of titanic stars, like final breaths sent hurtling across time. Radio waves stretch lazily across the cosmos, slow and wide, carrying the hum of ancient light. Your eyes evolved to see a narrow strip of this spectrum, just enough to navigate the Earth, to find food, to read expressions, to follow the glow of a fire. But the universe does not confine itself to what you can see. It radiates in every direction, at every frequency, all at once. And so, there are telescopes that see differently. Machines built not to magnify light, but to translate the invisible into vision. They give us images made not with color, but with energy. Infrared telescopes reveal the warmth of stars still cradled in dust. Through them we see stellar nurseries, places where stars are born inside, clouds too thick for visible light to pass through. The Orion Nebula, which looks like a faint smudge in the sky to the naked eye, becomes a riot of motion and flame in infrared. X-ray telescopes catch the aftershocks of collisions, the violence of collapsed stars spinning at impossible speeds. And radio telescopes listen, not for sound, but for the long, low echoes of the cosmos, stretched out over distance and time. Somewhere, a pulsar spins, what's left of a massive star, collapsed into a dense, fast-spinning core. It beams energy from its poles like a cosmic lighthouse, sweeping across the universe with astonishing precision. Some spin once every few seconds. Others, called millisecond pulsars, rotate hundreds of times per second. Their beams flash in perfect rhythm, ticking like a celestial metronome. You can't see them with your eyes, but radio telescopes catch the pulse. They map the heartbeat of dead stars, still sending signals from the dark. And above you, there are storms. Not the kind that roar with thunder or pour with rain, but storms of magnetism and energy, rippling across interstellar space. Charged particles thrown out by flares on distant stars. Winds of cosmic rays drifting between galaxies. These storms do not light up the sky in ways you'd recognize, but they're there, moving silently, invisibly, through the background of your life. Some of them strike Earth's magnetic field and dance as auroras. Others pass through you without notice, as indifferent as starlight. Even in darkness, you are surrounded, bathed in radiation from the cosmic microwave background, the faint afterglow of the Big Bang itself. This light is nearly 14 billion years old, stretched and softened by the expansion of the universe until it is no longer visible at all. But it is still there. It fills the sky equally in all directions. It whispers that everything began with light, and that some part of that light is still with you. You don't feel it, you don't see it, but it surrounds you. It's strange to think that the sky we know, the one passed down through generations of stargazers and sailors and storytellers, is mostly empty of the universe's light. Most of what's out there isn't luminous in the ways we can perceive. Most of it is hidden, revealed only through technology, patience, and imagination. We've built eyes to see what we cannot, and what we've found is astonishing. The galaxy is not a still pond, it's a churning sea. Star-forming regions glow in infrared like embers in fog. Black holes, though invisible themselves, reveal their presence through X-rays as they tear matter from orbiting stars. Quasars, a kind of active galactic nucleus, can radiate energy so intense it can be detected from billions of light years away, though no human has ever seen one directly. Even our own sun, if viewed in ultraviolet, appears violent and restless, a surface of boiling arcs and magnetic chaos. The more we look in invisible light, the more we realize how limited our ordinary vision is. Not flawed, just incomplete. What feels like a quiet, peaceful night sky is actually a broadcast. Continuous, expansive, layered with signals we were never meant to detect unaided, but now we do. We've built machines that extend our senses, and through them, we've discovered that space is not silent, it is singing. Right now, radio waves from distant galaxies are sliding past you. X-rays from ancient explosions are threading through your atmosphere. Microwaves from the dawn of time are passing through your skin. You are not separate from these things. You are inside the storm, inside the spectrum, inside the glow. And still, to your eyes, the night is calm. That's the illusion and the wonder. We live in a world where the invisible is just as real as what we can touch, where stillness hides motion, where darkness hides light. And in that hidden world, the universe carries on, spinning, bursting, sending its energy outward, indifferent to what we can or cannot see. But now, you know it's there. The sky is glowing in colors your eyes can't name. The stars are talking in frequencies your ears can't hear. And the space around you is never truly empty. You are surrounded by light you will never see, and somehow, that makes the night feel even more alive. There's something comforting about looking up and seeing familiar shapes in the sky. The dip of Orion's belt, the arc of the Big Dipper, the soft sprawl of Cassiopeia. We learn them as children, these constellations, like celestial handwriting passed down from the past. They seem eternal, almost sacred, as if the stars themselves had arranged their positions just for us, just so we could trace them into meaning. But the truth is softer and stranger. Those patterns were never really there. They were stories we told to tame the sky. The stars don't form pictures. They don't cluster into hunters or swans or bears by design. The constellations are artifacts of imagination, dot to dot. Sketches mapped across the heavens by people trying to bring order to vastness. When you stare at Orion, you're not seeing a hunter with a raised club and a belt of stars. You're seeing a handful of suns, scattered across tens or hundreds of light years, joined by invisible lines that exist only in the human mind. The stars are not near each other. They are not part of a group. They just happen to lie in roughly the same direction, like distant headlights aligned from where you stand. Still, we drew the lines. We gave names to the shapes, because that's what we do when we look into the unknown. We narrate it. We cast our myths into the night sky and let them settle there, glowing. In ancient Greece, Orion was a mighty hunter, flanked by his dogs and locked in an eternal battle with a bull. But look through the eyes of different cultures, and that same arrangement becomes something entirely different. The Lakota saw a handprint, the Babylonians saw a shepherd. In the Solomon Islands, Orion's belt was the mast of a canoe. In Australia, parts of Orion were said to be a hunter being pursued by a group of women. Even the shape of the Dipper, so instantly recognizable to many in the West, was seen as a plow, a ladle, a chariot, a camel's tail. The stars don't change, the stories do, and there's a kind of quiet beauty in that. It means the sky is not one story, but many. Not a single map, but 1,000 overlapping ones, drawn and redrawn with each generation. Every culture looked up and saw reflections of themselves, of their fears, their gods, their animals, their heroes. The constellations are a mirror held up to human imagination across time. They remind us not only of where we are in the universe, but of how long we've been looking up. Some of these stars will disappear. Some will drift or fade. The patterns we know now are only temporary. Over tens of thousands of years, the stars themselves will shift due to their own motion through space. They orbit the galaxy just as we do, and slowly, imperceptibly, they move. A constellation that looks perfect now will become lopsided, stretched, unrecognizable to future eyes. Even the North Star hasn't always been Polaris. The Earth's axis wobbles over millennia, and so the stars we navigate by today are not the same ones that guided ancient travelers. Yet in the moment, the illusion holds. We see the shapes and believe in them. not as facts, but as companions. The sky becomes familiar. It becomes something we can read, even if what it tells us is less science than story. And that's okay, because wonder doesn't need to be accurate to be real. You can know that Orion's stars are light years apart and still feel a thrill when you find him rising over the trees. You can understand that those lines are imaginary and still trace them with your finger, connecting them the way your ancestors did in cold fields and high mountains and quiet deserts. It's a strange comfort to know the pictures are false and yet still feel their presence, like seeing animals in clouds or faces in wood grain. The constellations are the universe humoring our need for meaning. They are not what's there, they are what we bring, and maybe that's why they matter. Because in a universe so vast it barely notices us, we drew something of ourselves into the stars. We marked them with our hopes and our fears, our gods and our monsters. We looked into the dark and sketched shapes that told us we weren't alone, not because we believed the stars belonged to us, but because we belonged to the act of seeing them. There's no rule that says the sky must make sense, and yet we made it make sense anyway. We connected the dots, we told stories, and the stories became maps. So tonight, when you look up, try to find the patterns, trace them with your thoughts, call them by their oldest names. But also know this: the sky isn't fixed. The pictures you see are only one version of what the stars can be. If you looked long enough, or from a different place, or through different eyes, you might see something else. A dragon, a dancer, a river, a silence. The stars are still there, but the meaning is yours. At first glance, the stars seem steady. They hold still in the night, unwavering and silent, as if frozen in time and space. Their light feels constant, like it's always been there, like it will always be. But if you watch long enough, or if you watch with the right tools, you begin to notice something else. A subtle rhythm, a flicker here, a soft dimming there. Some stars do not stay the same. They pulse, they vanish, they return, they breathe. These are not accidents. They are not broken stars or fading ones. They are doing something ancient and precise, something written into their very nature. Cepheid variables, for example, expand and contract in a rhythmic cycle, their light growing brighter and dimmer in a pattern that repeats with exquisite regularity. It's not a flicker like a candle caught in wind. It's a heartbeat, slow and enormous. Some beat once every few days, others every few weeks. The changes are not sudden. They are tides of brightness, moving in and out like breath through lungs the size of suns. The cause is a kind of internal struggle. The star's outer layers heat up, expand, cool, and collapse inward again. It's a balance of pressure and gravity, of energy building and releasing. From far away, this dance appears as light that pulses, bright, dim, bright again. And we've learned to read that pulse like a signal, because the timing of the pulse tells us how luminous the star truly is. And when we compare that to how bright it looks from Earth, we can calculate how far away it is. Cepheid variables became our first cosmic yardsticks. They helped us map the universe. Another kind of variable star, called RR Lyrae, does something similar, but on a different scale. These stars pulse faster, often over the course of hours instead of days, and they tend to be older, scattered across the halo of the galaxy like ancient beacons. They, too, help us measure distance. Their rhythm is like a code. Once you understand it, you can unlock where they are and how the galaxy is shaped around them. But not all blinking stars pulse from within. Some fade and return because of something else entirely. Another star moving in the way. These are eclipsing binaries, pairs of stars orbiting each other in such a way that one occasionally blocks the other from our view. When that happens, the total light we receive drops. When the eclipse passes, the brightness returns. If you plotted the light over time, it would form a pattern, a soft wave of light and shadow, repeated endlessly. A stellar eclipse, like clockwork, telling us about the size, mass, and temperature of each star in the pair. There are other variable stars too, ones that brighten unpredictably or fade over long years. Some are surrounded by swirling clouds of dust that shift and scatter their light. Others flare up violently, shedding layers or igniting unstable reactions in their cores. Some stars blink like fireflies, others dim like dying embers, glowing faintly before returning to full blaze. Each one tells a story written in flickers, and though they seem distant, these flickering stars have changed how we understand the cosmos. In 1923, a single Cepheid variable observed in the Andromeda galaxy revealed that Andromeda was not just a nearby gas cloud, as many had thought, but a vast galaxy all its own, millions of light years away. That one blinking star reshaped our sense of scale. It cracked open the edge of the known universe and showed us that the cosmos was much larger than we imagined. Since then, we've used these stars to measure not just distances, but time itself. The rate at which distant galaxies are moving away from us, something called the Hubble constant, was calculated in part by observing Cepheid variables. Their pulse helped us trace the expansion of space. Without their steady rhythm, we might still be guessing at how old the universe is or how fast it's growing. They are more than just curiosities. They are instruments, and they're beautiful too. A star that pulses isn't failing. It isn't dying. It's alive in a way that we can finally witness. You can imagine it, not as a perfect point of light, but as something vast and living, expanding outward, breathing in, exhaling brightness into the dark. It doesn't rush. It doesn't stutter. Its rhythm is older than language. Sometimes, late at night, astronomers point their telescopes toward these stars and let them record the slow rise and fall of light. They watch for hours, for nights, for weeks, following a single blink across the void. It's a kind of listening, a kind of witnessing, because in that flicker is more than light. There is movement, distance, time, and sometimes even answers. But mostly, there's awe, because you can look up and see what seems like a single speck of light and know that it is not steady, know that it is changing, know that its brightness is rising and falling with a rhythm carved by forces so immense we can barely describe them. You are seeing not just a star, but a message, a signal, a breath. The sky is not still. The stars are not frozen. Even in their silence, they speak. And a blinking star is not a mistake or a failure. It is the heartbeat of the cosmos, echoing through space, reminding you that nothing is ever truly still. The moon looks like it glows. On a clear night, when it's full and high above the trees, it can feel like a lantern hung for you alone, casting pale shadows that stretch quietly across the ground. It lights up rooftops, fields, the curve of your windowsill. You can read by it, walk by it, feel strangely watched by it. It seems to shine with its own silver hush, cold and ancient, something separate from the world it peers down on. But the truth is gentler and stranger. The moon doesn't shine, it reflects. Its glow is not its own, but a borrowed thing. Sunlight, fierce, golden, blinding, hits the moon's surface and bounces back, softened, filtered through dust and craters and distance. By the time it reaches you, it is dimmed by a factor of hundreds of thousands. The full moon is still 400,000 times dimmer than the sun, but because it's surrounded by darkness and because your eyes adjust, it feels like a light source in its own right. It feels alive, and there's something beautiful in that, something quietly humbling, because all that silvery light you've ever loved, the kind that ripples across ocean waves, or glints on snow, or turns a familiar street into a dream, is just sunlight. In disguise, a reflection, an echo. Still, it doesn't feel like that. Moonlight has a different weight to it. It doesn't press down the way sunlight does. It doesn't expose, it reveals. It's slower, quieter, almost internal, like it's not lighting the world so much as pulling it gently into focus. There's a reason poets write about moonlight. It feels like memory, and though it's only a reflection, the moon can still change everything. It can cast shadows strong enough to read by, in places without artificial light, deserts, forests, mountains. The full moon can be bright enough to confuse animals, and even humans. Some people find it hard to sleep during a full moon. Others feel restless, uneasy, stirred up in ways they can't quite explain. For centuries, people have blamed the moon for strange behavior, for surges in emotion, for dreams that feel too vivid to ignore. There's no strong science behind the idea that the moon changes our mood, but the feeling remains. The moon feels close, it feels personal, and for many creatures, it is. Corals in the ocean time, they're spawning to the light of the full moon. Grunion fish swim up onto beaches only during specific phases of the lunar cycle to lay their eggs. Birds adjust their migration based on moonlight. Predators hunt more or less, depending on how bright the sky is. Some frogs call louder during full moons. Some insects hide more. Even plants, in subtle ways, can respond to the moon's rhythms. The world is more tuned to that echo than we often realize. And there are human rituals too. Calendars built around lunar cycles, holidays and fasts tied to its phases, cultures that watched the moon's changing face and saw gods, goddesses, omens, entire mythologies sculpted from the way its light waxes and wanes. The moon is the closest celestial body to us, and still, it holds a kind of mystery. We've walked on it. We've brought back pieces of it. We know it's a rocky, airless sphere, with no light of its own. And yet it still feels like a companion. Maybe it's because it follows us, rising and setting, waning and returning. You never really lose the moon. It just changes, becoming something else before becoming itself again. A sliver, a half, a whole, a memory. And when it's full, when the sky is clear and the world is quiet, it can feel like a second sun, one meant not for warmth or growth, but for reflection, not just of light, but of thought, of feeling, of what it means to be a creature moving through time. Moonlight isn't sunlight, not really. It's gentler. It's been softened by distance and texture. It's bounced off a body that's been scarred by impacts, shaped by gravity, caught in eternal orbit. But somehow, it still reaches us. It spills through blinds. It paints lakes. It touches your skin without burning. Even in reflection, it feels whole. That's what's so strange and wonderful. The moon could be just a mirror, and still it becomes a presence. It could be just a rock, and still it's a symbol. It could be nothing but an echo, and still it stirs something that light alone can't. It becomes story, memory, rhythm. It becomes the reason some creatures wake, the timing of tides, the shape of songs. So, the next time you see it, full or crescent, rising or fading, remember that its glow is not its own, that it's sunlight, softened, firelight, turned quiet, and still, that quiet light will follow you through forests, over oceans, across rooftops and empty roads, not because it needs to, but because it can. Because even a reflection can change the night. The sky looks still. It seems honest, open, infinite, simple in its vastness. Stars scattered like glitter, the arc of the Milky Way stretching from horizon to horizon. You look up and imagine you're seeing everything there is to see, as if the night is laying itself bare, offering you the whole of space in a single glance. But the truth is stranger, more delicate, more hidden, because much of what holds the universe together, much of what shapes the sky you see, is invisible. There are forces above you that don't shimmer or shine. They don't emit light or heat or sound. You can't touch them. You can't point at them. But they are there, woven into the structure of everything. Dark matter, for example. A name that sounds ominous, but really just means we don't know. We can't see it. We can't detect it with ordinary instruments. And yet, it moves galaxies. Without dark matter, the outer stars in spiral galaxies would fly away like beads from a broken necklace. Their speed doesn't make sense unless something massive and unseen is holding them in place. That something outweighs all the visible matter we can observe. It shapes the way galaxies spin, the way clusters of galaxies form, even the way light travels across the cosmos. But it's invisible. It's a shadow we can't step into, a scaffolding we know only by what it holds in place. And that's not the only unseen architect in the night. There's also gravity, not just pulling, but curving space itself. When a massive object sits in the universe, it doesn't just attract things, it warps the fabric around it. Light, which always travels in straight lines, finds itself bending through space that's been gently folded. Like sunlight, passing through water, starlight can be distorted as it moves past a massive object. This is gravitational lensing. It's not a trick, it's not an illusion, it's space, bending. Sometimes we see it as rings of light, Einstein rings, formed when a distant galaxy is perfectly aligned behind a closer one. Sometimes we see stretched arcs, smeared across telescopic images like the sky itself was melting. These distortions are evidence of things. If you could rewind the sky, night by night, year by year, you'd notice something peculiar. The stars would wheel around in familiar loops, circling the pole or rising and setting in fixed patterns. But a few bright points would behave differently. They'd meander, tracing lazy curves and loops across the constellations, sometimes moving forward, sometimes backward. Unlike their stellar companions, these lights wander. The ancient Greeks noticed this too. They called them planetes, wanderers. It was their way of acknowledging something subtle and strange. Not everything in the night sky holds still. Not everything obeys the script of the stars. Some things shift, some things drift. Tonight, if the air is clear and the moon is down, you might see one of them. Maybe it's Mars, glowing with a dull red fire. Or Jupiter, huge and steady, a lighthouse among the scattered diamonds of the Milky Way. Venus, when it's out, is unmistakable. So bright it can appear before sunset, outshining every star. So luminous it can cast a faint shadow if you know where to look. A shadow made not by firelight or lamplight or even the moon, but by a planet. They don't twinkle the way stars do. That's one way to tell them apart. Stars are so far away, their light is just a pinpoint, easily bent and blurred by the turbulence of Earth's atmosphere. But planets are closer, bigger in the sky. Their light is steadier, more like a tiny torch than a flickering spark. And if you track them over weeks or months, you'll see them change position, slipping between constellations, overtaking stars that once flanked them. Their paths are winding stories drawn in slow motion across the dome of night. And though we see them as lights, each one is a world. Jupiter, king of the planets, has storms bigger than Earth, a magnetic field so strong it could strip the electronics from a spacecraft. Its moons are miniature solar systems. Europa with its ice and ocean, Io with its volcanoes, Ganymede with its magnetic heart. And yet you can see them from your backyard. With just a pair of binoculars you can watch them, line up and shift, tiny pinpricks orbiting a brighter one. Watching them is like seeing a clockwork model, a slow ballet of light and gravity ticking along just above your head. Saturn too appears as a golden glow, but with a telescope, you'll see the rings, delicate, improbable, beautiful. A reminder that the things we take for granted as single points of light are often vast, elaborate systems of their own, complex, layered, alive in ways we're still trying to understand. And then there's Mars, dry, dusty, red. Sometimes it shines with a fiery intensity, other times it fades almost to invisibility. It comes and goes in brightness because its orbit is an ellipse, bringing it closer to Earth every 26 months or so. When it draws near, you can almost feel it, not with your skin or your breath, but with that part of your mind that's always reaching outward, the part that knows, without needing to be told, that another world is passing close, that right now, a place with mountains and craters and frozen poles is shining into your eyes. The sky above us is a stage of slow drama, and the planets are its travelers. Their movement isn't random. It's the graceful motion of orbits, governed by invisible hands. Gravity pulls them in endless ellipses, looping around the sun in paths that never quite close, always a little offset, always drifting forward through time. And from Earth's shifting point of view, these smooth orbits look like wandering paths. Sometimes a planet seems to move backward for a while, a motion called retrograde. It's not truly reversing, just a trick of perspective, like two cars on the highway passing each other at different speeds. But even knowing that doesn't take away the wonder. You are standing still, or so it seems. But everything above you is in motion. The stars hold their places in the grand wheel of the galaxy. But the planets, they walk the sky. And if you follow them long enough, night by night, they begin to teach you something that no calendar can. They teach you time in a different way, not by numbers, but by patterns. They remind you that movement can be slow and still sacred, that drifting doesn't mean lost, that a wanderer is still following a path. Long ago, these same points of light guided sailors, inspired myths, marked seasons, were named for gods, and still they pass over us, quiet, consistent, often unnoticed by the city-lit eyes of the modern world. But they're still there, keeping their appointments with the stars, moving through the heavens not as points, but as places, as worlds. If you find yourself beneath a clear sky sometime soon, look up. Find the bright ones that don't twinkle. Watch them, if only for a minute. You won't see them move tonight. Not really. But if you come back tomorrow, and the day after, and the day after that, something will shift. A brightness will have edged into a new constellation. A new guest will have appeared in the sky. You are not just watching light. You are watching worlds drift past. If the night sky had a voice, you might expect silence. After all, when you stand beneath it, wrapped in darkness and distance, the first thing you notice is the quiet. It settles around you like a blanket. No engines, no chatter, no buzz of screens or static of thoughts. Just the hush of wind in trees or the rhythmic rise and fall of your breath. The stars say nothing. The moon glows in silence. The planets drift without sound. But this quiet is not the whole truth. Not even close. The sky is louder than it looks. Start with meteors. They fall so fast, faster than sound, slicing through the atmosphere in streaks of light. Most burn up high above, far out of reach. But sometimes, only sometimes, and only if the night is still enough, you can hear them. A faint crackle, a whispering hiss, a dry electric breath. For centuries, this was considered impossible. How could something so high produce sound so quickly? The answer lies in electromagnetic energy, pulses generated by the meteor's passage, reaching the ground almost instantly, vibrating objects nearby, leaves or glasses or your own hair. It's not the meteor you hear, but the world responding to it. You're listening to the sky with your surroundings, and meteors are just the beginning. Comets, those icy wanderers that sweep in from the edges of the solar system, are colder and quieter still, or so it seems. But when space probes listen closely, they reveal something stranger. The European Space Agency's Rosetta spacecraft once recorded a low, rhythmic pulse from Comet 67P, a sort of oscillating croon, not quite music, not quite noise. Scientists call it a song, though we can't hear it unaided. It was likely created by the comet's magnetic field interacting with solar radiation, but it sounded like something alive, something breathing, a world humming to itself. And then there is the wind, the solar wind, blowing endlessly from the sun in all directions. Not a breeze, not air, but a flow of charged particles riding invisible fields. When this stream reaches Earth, it bends and curls around us, caught by our planet's magnetic shield. Most of it passes by unseen, unheard. But where it slips into our poles, something extraordinary happens. The particles interact with our atmosphere, exciting atoms, releasing energy. This is how auroras are born. You've seen the photos. Curtains of green and violet, rippling and folding like silk in a current. But the aurora does more than shine. It murmurs. It hisses. In the highest latitudes, under rare conditions, people have reported faint sounds during strong auroras, snaps, crackles, pops. Too soft to record easily, too fleeting to prove, but the reports persist. One theory suggests it's electrostatic discharge, the atmosphere building up and releasing small bursts near the ground. Another is that it's something internal, a sound you feel as much as hear, like the faint pressure of thunder before it arrives, a presence without a voice. But the sounds aren't always audible. Some of them hum beneath our hearing, low and slow, like the groaning of the planet itself. Earth is constantly bathed in radio waves, from the sun, from Jupiter, from distant quasars. The entire cosmos is a storm of electromagnetic noise. It's not silence up there, it's signal, and we can translate it. Radio telescopes stretch their arms to the stars and catch this noise, not like microphones, but like nets. They collect the unseen, the unfelt, and turn it into sound. The hiss of a pulsar spinning 30 times a second, the warble of plasma waves, the chorus of whistlers as lightning on Earth echoes through space and returns transformed. The data becomes audio, and suddenly, you're not just looking at the sky, you're listening to it. Some of it is beautiful, some of it is eerie. Saturn's rings produce a constant static, a million frozen particles whispering past one another. Jupiter's magnetosphere roars with a sound like ocean waves mixed with machine growls. Black holes emit nothing directly, but the matter falling into them, spiraling inward in its final moments, sends out X-rays and signals that, when converted, sound like a rising scream. Even in death, the cosmos makes music, and what a strange orchestra it is. No strings, no woodwinds, no percussion, just gravity and plasma and magnetism, just particles and space. But still it plays, a symphony without ears. You are a part of this, even now, even if you don't notice. Your body is moving through a field of cosmic radiation. You are walking through a sea of waves, some made by stars long gone, some made by storms on planets you'll never visit. If you could suddenly hear it all, not with your ears, but with some deeper sense, it would be overwhelming. A flood of pulses and tremors, waves and echoes, the long static of creation still vibrating across space. But, instead, you hear the quiet. You hear wind in leaves, a distant car, maybe nothing at all. But the silence you know is only surface level. Underneath, the universe hums. So the next time you look up and see nothing but stillness, remember this. You are standing in the middle of a storm of sound, a quiet, louder than any voice. You are listening to a concert that began long before you arrived and will continue long after you're gone. One made not for the ears, but for the soul. There's music in the stars, even if you can't hear it. On a clear night far from city lights, if you let your eyes adjust and tilt your head back just right, you'll see them. A few thousand stars, maybe. Dots scattered across the dark, like a delicate spill of sugar on velvet. Some bright, some dim, some steady, some faintly flickering. It feels like a lot. A vast, endless sky, overflowing with light. But it's not. It's barely anything at all. Most people can see between 2,000 and 3,000 stars with the naked eye under perfect conditions. That might sound generous, but when you realize the Milky Way alone contains something like 100 billion stars, the scale collapses. What you're seeing is less than a drop in an ocean, not even a full breath in a lifetime. You are looking at 0.00003% of your own galaxy, and yet it's enough to feel infinite. The irony is that this illusion of abundance has shrunk over time. In cities, under the hum of streetlights and glowing windows, the stars fade, not because they're gone, but because we've buried them under our own light. Our eyes are adapted for contrast, not brightness. When the sky glows orange or pale blue from artificial haze, the stars lose the fight. One by one, the faintest vanish, then the modest ones. Soon, only a handful remain, stubborn and bright. The planets, maybe Sirius, maybe Vega. The rest are gone, drowned, not in clouds, but in convenience. We have lost the night, and with it, something else slips away. A sense of placement, of context. Our ancestors knew the sky in a way we no longer can. They saw it as a map, a calendar, a canvas for story and meaning. They knew where the constellations rose and how they shifted with the seasons. They read the stars as signs, not symbols. When they looked up, they weren't just gazing into space. They were locating themselves in the world. Now we glance at our phones instead. But there are still places, hidden corners of the world, where the darkness returns. Deserts, mountain ridges, remote islands. And when you stand in those places on a moonless night, something happens. Your eyes adjust, really adjust, and the Milky Way emerges, not as a concept or a term from a textbook, but as a real, living river of light across the sky. A band of fire and dust and stars too many to name, too distant to understand, stitched together in a slow shimmer. It doesn't feel flat. It feels like depth, like looking into a valley filled with glowing fog, like staring into the spine of the universe. And in those moments, the scale of it all becomes personal. You realize that most of what's out there, most of what's possible to see, is invisible to you right now. Not because of distance, not because of light years or redshift or speed, but because of us, our lights, our walls, our noise. The universe hasn't gone anywhere. We just covered it up. And yet, even the small glimpse we have is enough to stir something deep, because what we can see is beautiful, and what we can't see is vast. There are galaxies in the sky too faint for even the best telescopes. There are stars behind stars behind stars, layered so densely that even their combined glow barely registers. There are nebulae shaped like wings, and star clusters packed like jewels, all hidden just beyond the edge of our perception. We don't see them, but we feel their presence, like hearing a melody behind a wall. What we see is not the sky, it's the echo of it, an echo that carries the past. The light of stars born before language, before fire, before time, as we measure it. Some of the stars you see tonight may no longer exist, their light still en route, still painting the present with the colors of the past. Some are young and close, others are ancient and far, each point a time capsule, each one a whisper from across unimaginable distance, and all of it, even the brightest, is just a surface. We talk about space as if it's out there, somewhere above, but in truth, it begins just past the blue, just past the edge of sky, and from there, It goes on, deeper than we know, wider than we can dream, and though we live inside it, carried along by a planet orbiting a star, orbiting a galaxy that itself drifts through the void, we rarely feel it, rarely touch it, rarely look. But when we do, when we finally look up, really look, we remember. We remember that we're small, but not insignificant, temporary, but not meaningless, that our world is a bubble of light floating in an ocean of dark, and that beyond our cities, beyond our screens, beyond the noise and speed of daily life, there's still a universe waiting. It's not silent. It's not empty. It's not gone. It's only hidden. Every once in a while, the sky repeats itself, not in a way that feels obvious, like a season returning or a familiar constellation rising, but with a precision so deep and long it feels more like memory than motion, a pattern unfolding so slowly, stretched over decades and centuries, that it loops back around without fanfare. You wouldn't notice it unless you were watching for a long, long time. Longer than a life, maybe longer than a language, but it's there. Time, marked not in clocks or calendars, but in light and shadow. Take eclipses, not the quick, flickering kind you glance at through darkened glass or hear about on the news, but the pattern beneath them. The rhythm. A solar eclipse is a beautiful coincidence. The moon perfectly covering, the sun, just for a few moments, casting day into night. But it's not random. It happens in cycles. The most famous is called the Saros cycle, about 18 years and 11 days long. Every time it ends, it begins again. A nearly identical eclipse returning, shifted slightly on the globe, like a celestial echo, like the sky remembering what it did before. People noticed this long before they had names for it. The Babylonians tracked the cycle with nothing more than sharp eyes and steady hands, carving their records into clay. They knew when the sun would vanish and when the moon would go dark, and they passed that knowledge forward, generation after generation. To them, it wasn't math. It was magic. The sky keeping promises, the universe revealing itself in loops and returns. Even when empires fell, the sky stayed faithful. And it's not just eclipses. Other alignments follow their own rhythms, some slow, some slower. Venus traces a pentagram in the sky every 8 years, looping back to nearly the same place, like a dancer stepping through a remembered routine. Jupiter and Saturn meet about every 20 years in what's called a great conjunction, their two brightest lights almost merging into one. The moon wobbles on an 18.6-year cycle that tugs at tides and shifts the strength of eclipses. Some star patterns rise at the same time each year, marking solstices and harvests. Others drift over centuries, their meaning shifting with the cultures that named them. The sky is full of clocks we can't see ticking. Ancient people saw this. They didn't call it astrophysics. They called it sacred. They built monuments not just to worship, but to track. Stonehenge aligns with solstices. The pyramids of Giza face true north with eerie accuracy. The Maya charted Venus's cycle so precisely that their records rival modern astronomy. In New Mexico, a spiral carved into a canyon wall captures the dance of sunlight through a narrow slit, perfectly marking the summer solstice. Each year, no wires, no batteries, just stone and shadow. Imagine caring enough to carve a calendar into a mountain. These weren't accidents. They were conversations, long, patient ones, between people in the sky. If you look at the stars every night of your life, you start to hear the rhythm, the pauses and returns, the beats between the notes. You realize that time isn't something you measure with hands on a dial. It's something that moves above you, something vast and silent that wraps around your whole life and continues long after. It changes how you think. When you know the moon will rise in the same place again in 18 years, you stop rushing. When you understand that a star once marked the start of spring but now rises too late, you begin to feel the slow tilt of the planet itself. When you see an eclipse, you know someone else saw centuries ago. Not metaphorically, but literally, the same shadow in the same pattern. You feel smaller, but not in a painful way, in a freeing way. You're part of something too big to break. And these cycles don't stop when we forget them. The Saros continues, even if no one watches. The Venus pentagram spins on. The eclipses come and go. The sky keeps appointments older than cities, older than writing, older than stories themselves. You don't need to understand the math to feel it. Just look up. Just wait. And that's the strange beauty of it. You are surrounded by repetition, but it never feels the same. Every full moon is different. Every eclipse casts its own shadow. Even the stars shift, ever so slightly, over lifetimes. The loops aren't perfect. They spiral. They drift. But they return. And in those returns, there's a kind of comfort, the reassurance that time isn't only something that moves forward, it also moves around. And in doing so, it brings us back, not to where we were, exactly, but close enough to remember. So the next time you hear of an eclipse or watch a bright planet drift low in the evening, think of it not as a one-time event, but as a whisper from the past, a message written in shadow, read by countless eyes before yours. A moment in a long, slow song you're lucky enough to hear, even if just once. And if you pay attention, you might catch the tune. It's not just starlight that marks the sky. It's time itself, looping softly above us. The earth has a shadow, not the kind cast by buildings or trees, not something you can see draped across the ground, but a massive, invisible cone that stretches behind our planet like a dark ribbon in the solar wind. It's not static. It's not still. It glides through space with us, perfectly shaped by sunlight, perfectly aligned with our orbit, always pointing away from the star that gives us day. It's there now, extending into the vastness for over 1 million kilometers, long and silent and cold. Most people have never thought about it. Fewer still realize they've seen it. You might think the moon's phases are caused by this shadow, that the waxing crescent or gibbous shape is the result of Earth's dark veil sliding across the lunar face. But that's not true. The phases come from the dance of sunlight on a round surface. They're the product of angles, not shadows. The moon is always half lit by the sun. We just see different slices of it depending on where we are and where it is. The darkness you see isn't Earth's doing. It's geometry. But eclipses are another matter. During a total lunar eclipse, the Earth steps directly between the sun and the moon, and for a brief span, our shadow envelops that distant world. The moon doesn't vanish. It turns copper, crimson, rust. The light that does reach it has bent through Earth's atmosphere, scattering the blue, letting the red curve around the planet like a lens made of air. In a way, you're seeing every sunrise and sunset on Earth at once, projected onto the moon's surface. It's a moment when the sky turns, inside out. You stand on a planet casting its shape into space, and the moon, our quiet companion, passes through that shape, not behind us, but through the invisible fingerprint of our presence. For those few minutes, we are more than a place. We are an obstruction, a participant, a sculptor of shadow. You don't just live on Earth, you live within its reach, and the reach is longer than you think. Earth's shadow stretches 1.4 million kilometers into space, tapering gradually, like the tail of a comet you can't see. It points away from the sun with precision, marking the night half of our world, yes, but continuing far beyond the atmosphere, beyond the moon, into the deep silence. It's a dark corridor where sunlight cannot go, and yet it holds a kind of light all its own. The memory of eclipses, the quiet path of transits, the echo of every object that slipped through it unnoticed. Satellites, space stations, astronauts, all of them have crossed into this shadow. They feel it, not as darkness, but as a sudden drop in warmth, a shift in the hum of solar panels, a reminder that space is not uniformly lit. Even here, Light has boundaries, and those boundaries are shaped by you. If you've ever stood beneath a lunar eclipse and felt the air grow strange, if you've watched the full moon vanish slowly and wondered how it could still glow, then you've witnessed Earth's shadow. You've seen the fingerprint of your home on the universe, and chances are you didn't even know it. That's the quiet power of it. We think of shadows as passive, as the absence of light, but Earth's shadow is active. It defines what light cannot touch. It determines where the stars go dark, if only for a moment. It's a sculptor's tool, carving arcs across the cosmos, placing boundaries where none existed before. And as we orbit, as we spin, that shadow spins too. It trails us in an endless loop around the sun, moving faster than any cloud, deeper than any night. It never stops. And while we sleep, while we dream, while we forget that anything above us moves at all, the shadow keeps pace. It's there during sunrises, pulling backward into space while the sky brightens. It's there during midnight, stretching behind you while you look at constellations. You live in the middle of a great lantern, yes, a world lit on one side by a star, but also in the heart of its absence. You cast a shadow so long it could cradle other worlds. One day, it might. When future missions head to deep space, to Mars or beyond, they will pass through this corridor of shadow. They'll slip out of the sun's light, just for a moment, and be held in the dark by Earth. No ceremony, no marker, just the quiet shift of heat, the dimming of solar arrays, and the long stretch of night that follows them for thousands of kilometers. And they'll emerge again, because the shadow doesn't hold you, it only passes through. So the next time you see the moon rise, full and bright, remember that it has passed through you. Not through your hand or your house or your town, but through the shape your planet carves into the sky. And remember that you live on a world not only of light, but of shadow, one so vast it leaves fingerprints on the moon, so precise it bends through air and leaves blood-red circles in its wake. It's not just the stars that mark the night. It's the Earth, quietly sketching its presence across the sky. The sky remembers, not in the way we do, with names and feelings and pictures pressed between pages, but in light and position and silence. It keeps time without ticking, marks anniversaries without calendars, and repeats itself with a patience that feels impossible. You can ask it what it looked like the night you were born, and it will tell you. Not in words, but in angles and arcs and alignments that haven't changed. Not really, not yet. Even now, drifting through time, the stars return. Night after night, they rise and fall in patterns older than language. The constellations swing across the heavens like pendulums on a clock you can't wind. And if you learn to read them, they will show you not only what is above, but what was and what will be. Star charts are time machines, plain paper mirrors of the infinite. Astronomers can rewind the sky like a film, play it backward 1,000 years, 100,000, and watch it shift and drift and return again. The sky has always held meaning, long before we drew borders, before we built cities or machines or even myths. Ancient sailors crossed vast oceans using nothing but the stars, their positions etched in memory, their names whispered like compass points. They watched as Orion tipped over the horizon, as Sirius blazed in the pre-dawn dark, and they knew where they were and where they were going. No lights, no satellites, just stars, and the trust that they would rise where they always had. Even now, some people live by them, not metaphorically, not poetically, but practically. There are cultures where the heliacal rising of a certain star marks the start of a season, where the return of a specific constellation means it's time to plant or harvest or celebrate. To them, the sky is a clock, a calendar, a storyteller. It doesn't just show time, it holds it, and it remembers for all of us. If you were to lie back beneath the open sky on a clear night and wait, really wait, you'd notice something quietly astonishing. The stars, shift. Imperceptibly at first, just a small nudge along the black canvas, but over the hours, constellations rotate, dip, and rise again. They march. They keep time in a language without sound. And if you know the language, if you've learned to hear in stillness, you can trace entire histories there. That same stillness is what once gave rise to myth. People saw animals and heroes, weapons and lovers in the stars because they were searching for memory, for meaning, for pattern. The sky became a place to store stories, a canvas too large to ever lose. The shapes we made there have lasted longer than empires. They've survived fire and flood and the forgetting of names. The stars don't just burn, they archive. Some stories are carved into the architecture of ancient buildings, stone observatories aligned perfectly with solstices or equinoxes, windows and doorways cut to frame certain stars on certain nights. They were markers, records, memory made visible. Entire civilizations lived and died with their eyes turned upward, not in longing, but in understanding. They weren't just stargazers. They were sky readers, timekeepers of the celestial kind. Even now, when we think we've outgrown such things, we still look up and wonder. We still make wishes. We still set dates for meteor showers and eclipses and comets with names. We still pause when the moon is full and luminous, as though it means something more than light. Maybe we've forgotten how to navigate by stars, but we haven't forgotten that they mean something. We never will, because the sky doesn't forget. It remembers the night you got lost and the one you fell in love. It remembers what the horizon looked like the day your ancestors first looked up and noticed. Venus, so bright, it cast shadows. It remembers the rhythms of fire and cold, of planting and reaping, of war and peace and silence. It keeps them all, in positions, in returns, in slow celestial loops that outlast every map we've ever drawn, and it's generous with its memory. You can go online right now and type in a date, any date, and there it is, the sky, just as it was, April 23rd, 1451, July 9th, 2021, the night your child was born, the night your grandparents fled. The sky doesn't judge which moments matter. It simply stores them all, in light and angle, and the steady geometry of orbits. You don't need a telescope. You don't need credentials. You just need to ask. Because the sky is always there, and it's always telling to you where you are in time. And while the stars do move, slowly, quietly, drifting apart across millennia, they move in such a way that their stories remain. The figures we draw between them may shift, may fade, but the memory doesn't vanish. It lingers in traditions, in the names of months, in solstice rituals and harvest festivals and lullabies sung to children about the moon. The sky has seeped into us. Its rhythms live in our language, in our sleep, in our sense of when things should begin and end. It is not just a backdrop, it is an archive, a living, moving, glowing history of everything that has ever looked up and wondered what comes next. So tonight, when the dark settles and the stars begin to show themselves one by one, think of what they've seen. Think of how many times they've risen and set over the same patch of ground. Think of the hands that once pointed them out, the voices that named them, the paths they lit across oceans and deserts and dreams. You are not just looking at the stars, you are looking into memory. The sky has moods. Most nights, it hides them behind a quiet screen of stars, content to glow faintly and say little. But sometimes, it speaks louder. Sometimes it dances. Somewhere far to the north, or deep in the southern skies, you might look up and see the horizon whispering in color, not flashing like lightning or blazing like fire, but curling, weaving, slowly blooming into silent movement. It begins like a breath of pale green, then unfurls, brighter, richer, slipping into purple or red until it feels less like looking and more like dreaming. These lights, the Aurora Borealis and Aurora Australis, are not made of magic, though they feel like it. They are storms from the sun, transformed. Our star is not always calm. It breathes, too, but violently, sending out bursts of solar wind, streams of charged particles that race toward us across the vacuum. Most days, we don't notice. We're shielded by Earth's magnetic field, a kind of invisible shell that bends and funnels those particles away. But sometimes, when the wind is strong and the conditions are right, it guides them instead toward the poles, where they slip into our atmosphere and light it up from within. What you're seeing is a collision. Atoms in the upper atmosphere, oxygen, nitrogen, getting struck by electrons, moving faster than anything you'll ever feel. And when they collide, they glow. Oxygen gives us green and red. Nitrogen gives us purples and blues. The exact color depends on altitude, energy, the mix of gases. It's science, yes, but it doesn't feel like that when you're underneath it. When the sky itself becomes kinetic, like it's breathing color in real time, it stops being something to study and becomes something to feel. People travel thousands of miles to see the lights. They wait through freezing nights, long stretches of nothing, blank skies and tired eyes. Because when they come, if they come, they change the shape of the sky. They ripple like water, flicker like thought. They stretch like long fingers across the stars, undulating in ways no stillness can predict. You can't plan them, only hope. You can't summon them, only watch. And when they move, it's as if the sky has remembered how to dance. There are places in the world where this dance is ancient. The Sami people of northern Scandinavia call the northern lights Guofsahas, meaning the light you can hear, and sometimes you can. There are rare reports of soft crackles, faint hissing, like static whispering across snow. Science has debated this, puzzled over how sound could arrive without delay when the aurora plays so high above. But the stories persist, and some say it happens only in the deepest quiet, the kind of silence most of us never reach anymore, a silence thick enough for the sky to speak. Indigenous cultures have watched these lights longer than there's been written language. Some saw them as spirits, ancestors dancing, guiding, watching. Others believed they were omens, or messages, or fires kindled by gods. What's striking is how many of those stories describe them with reverence, not fear. The aurora doesn't rage, it doesn't crash, it doesn't blind, it hums, it glows. It arrives like a guest, uninvited but deeply welcome. And it's not just beauty, it's information. Auroras tell us what the sun is doing, even from millions of kilometers away. They're signs of space weather, a kind of atmospheric echo of distant violence. Solar flares, coronal mass ejections, shifts in magnetic fields. All of these leave fingerprints on our sky. We track them now with satellites and sensors. But for thousands of years, it was the aurora that told us something had changed, that the sun had spoken and the earth had answered in light. The dance is unpredictable. No two auroras are ever the same. Some swirl in tight spirals. Some sweep across half the sky in ribbons that seem to flutter in a wind you cannot feel. Sometimes they burn bright and vanish. Other times they linger, shifting in subtle layers, as though the night has decided to wear its colors inside out. They stretch from one end of the horizon to the other, a moving archway into something older than memory. If you've never seen one, it's hard to explain why it feels so personal. Maybe because you don't just see the aurora, you feel it moving around you. It wraps the sky. It pulls your gaze upward. It makes the stars seem small for a moment. You feel tiny, but not lost. You feel like part of a performance that was written long before you arrived. And when it fades, as all auroras do, it doesn't disappear so much as retreat, back into the sun's breath, back into the silence where it was waiting. There are lights we create, the glow of cities, the flare of engines, the pulse of machines, but they're nothing like this. City light pushes against the sky. The aurora invites it closer. It doesn't overpower, it reveals. It reminds us that the atmosphere isn't just a shell we live under, but a place where Earth and cosmos meet and exchange energy in color and shimmer and motion. Even the name, Aurora, is a memory. It means dawn, a reminder that even in the darkest part of the night, there's light waiting to return, not from below the horizon, but from above it, from particles and fields and forces we can't see, converging to make something fleeting and enormous and soft. The next time you find yourself under a wide sky, pay attention to its stillness. Watch for a hint of green at the edge. Look for movement where there should be none. And if the aurora appears, even faint, even slow, let it take your breath in that gentle way only wonder can. Because for a brief moment, you are watching space become art. When you gaze up into the calm blackness of night, what you're seeing feels eternal. A sky full of stillness, pinpricks of white scattered across an infinite dome, all suspended in silent perfection. But that stillness is an illusion. The stars are not quiet. They are not still. They are furious, living engines of pressure and fire burning through time with relentless momentum. And sometimes they lose control. Sometimes they fall into each other. There are stars that orbit not in solitude but in pairs, locked in a gravitational dance that lasts for millions or billions of years. Some spin at great distances, others draw closer, slowly tightening their paths with each revolution. Over time, that closeness becomes fatal. They spiral inward, pulled by gravity and fate, until they meet. And when they meet, they merge, not gently, not quietly, but with violence beyond anything your mind can fully hold. When stars collide, they unleash light, radiation, matter. The universe ripples, time warps, space bends. The sky, which once seemed so passive, becomes a battlefield of unthinkable forces. Take neutron stars, the dense, collapsed remnants of giants. They're small, barely the size of a city, but so heavy that a single teaspoon would outweigh a mountain. When two neutron stars crash into each other, the collision is not just bright, it is history-making. In 2017, astronomers saw it happen for the first time. A flash of gamma rays, a gravitational wave, then light across every spectrum. A celestial broadcast, traveling millions of years just to reach us. From that one collision came gold, platinum, uranium, the elements that make up rings, electronics, the core of planets, the elements that make up you. Your blood carries iron forged in stars, but your jewelry may trace back to something even more rare. A stellar collision, a moment of destruction so powerful it manufactured precious metal from raw atomic violence. Gold is not born in the ground, it is born in chaos. And yet, the sky doesn't show us that chaos directly. It reveals only the echo, the soft afterglow. A supernova's light, traveling through space for centuries, reaches us long after the moment of impact. You could be looking at the aftermath of a death that happened when humans were still painting on cave walls. The Crab Nebula, a tangle of filaments near the constellation Taurus, is the remains of a supernova witnessed in 1054. Chinese astronomers recorded it like a comet that didn't move, a guest star. Today, it glows in radio, infrared, and visible light, the ghost of an explosion older than most nations. You may have already seen a light born in death. When you make a wish on a star, you could be speaking to the end of something. You might be catching the final flicker of a life that burned for billions of years and ended in a breathless shudder, releasing energy that will float through space until it hits your eye. And still, it appears gentle. Still, it calms. That's the trick the cosmos plays. It makes catastrophe beautiful. The night sky is full of these quiet disasters. They are not rare. They are not anomalies. They are the way the universe evolves. Stars are born and stars die, and sometimes their deaths are ordinary. Slow fades into white dwarfs, dimming over eons. But sometimes their ends are theatrical. Stars too massive to fade collapse instead, crushing themselves inward until the pressure triggers a rebound so immense it tears them apart. In that moment, they become something else. Supernovae, black holes, neutron stars, gas clouds that stretch across light years, and some of those fragments go on to create new stars, new planets, new chances for life. From one end comes the other. There is a strange kind of comfort in that, a balance you can't always see but is always there. Nothing is wasted. Nothing vanishes. Energy becomes light. Light becomes memory. The collision of stars births not just gold, but the conditions for new beginnings. We live in a universe that recycles itself on a grand, unknowable scale. A cosmos where even destruction has beauty and even death has purpose. There are people alive today, astronomers, physicists, artists, who devote their entire lives to watching these events unfold. Not because they can stop them, not because they can change them, but because they understand the value of witnessing, the importance of seeing something for what it truly is, even when it hides behind silence. Telescopes tuned to X-rays and radio waves search the skies for flickers, pulses, the subtle clues of a distant disaster. They look not for perfection, but for motion, not for serenity, but for story, because every flicker in the night sky is a sentence in a much larger story, a story of transformation, of cycles, of things falling apart and coming together in ways no one expects. And you, lying still beneath the stars, breathing gently into the dark, are part of that story too, not outside it, but within it, made of it. Tracing your ancestry not just to creatures and trees and oceans, but to stars that collided long before Earth ever formed. So the next time you look up and feel peace, remember what that peace is made from. It's built on wreckage, on heat and collapse and force beyond imagination. But it arrives quietly. It glows gently. It meets you where you are, asking nothing but your gaze. Somewhere out there, a star is spiraling toward another. Somewhere, a collision is beginning, and someday, maybe long after your own time has passed, its light will arrive, just beginning to shine. The moon and the sun shouldn't match. One is a blazing star 100 times wider than Earth, the other a lifeless satellite just over 3,400 kilometers across. They're not even close in size, but somehow, from our vantage point on Earth, they appear nearly the same in the sky. The moon is about 400 times smaller than the sun, and it just so happens to be about 400 times closer. That one ratio, that quiet coincidence, is what allows a total solar eclipse to exist. It's why we get that perfect ring of fire, that sudden darkening of day, that halo of light and science and mythology all at once. Any other alignment, even slightly, and it wouldn't happen. No dramatic shadow sweeping across continents, no corona glowing like a whisper, no crowds of humans craning their necks and gasping in awe. It's a balancing act the universe never rehearsed. It happened. There's something unsettling and wonderful about that. The idea that some of the most profound experiences we can witness from our planet are made possible by nothing more than the math of coincidence. We like to think beauty has purpose, that symmetry means design, that wonder must be earned. But sometimes beauty just occurs. Sometimes the sky gets lucky. Our galaxy, too, is a masterpiece born from chance and gravity. The Milky Way is a spiral, sprawling arms that curve outward like ink swirling in water. This shape isn't guaranteed. Some galaxies are elliptical, others chaotic and irregular, but the spiral arms of the Milky Way create the ideal environment for star formation. Dust and gas are pulled inward by rotation, compressed, ignited. New stars are born in batches, clustered like cosmic nurseries. The galaxy's spin helps renew itself. Without this particular shape, our sun, and all the life orbiting it, may never have emerged. Even the Earth's placement in the galaxy sits in a delicate sweet spot. We're far enough from the center to avoid the dangerous chaos of black holes and radiation, but we're close enough to see the arms, to watch the Milky Way stretch across the night sky like a river of fire and shadow. That glowing band isn't just beautiful, it's revealing. It shows you your place, not in the solar system, but in the vast geometry of space. Every time you see it, you're looking sideways through your own galaxy. You're watching the plane of something so large it contains everything you've ever known, and within that view, more coincidences unfold. Our atmosphere, just dense enough to scatter blue light and paint our skies. The curvature of Earth, giving rise to sunsets that bleed gold and crimson. The particular mix of nitrogen and oxygen and trace elements that allow light to bend, stars to twinkle, and auroras to shimmer like liquid music across the poles. None of it was crafted for spectacle, but spectacle is what we get. There's a tendency to call it fine-tuning, to say the universe is calibrated for life, or at least for perception. Maybe it is, maybe it isn't. But you don't need certainty to feel awe. You just need to notice how easily something might have gone differently. If the moon were a little closer or farther, if Jupiter hadn't formed to shield us from so many comets, if our sun had been a bit more volatile, or if we orbited just a few million kilometers nearer. The conditions for life are narrow. The conditions for wonder may be even narrower. And yet, here we are, able to stand outside at night and witness the flicker of a setted satellite against a velvet backdrop, or the arc of a meteor slicing briefly through atmosphere, able to watch shadows of planets cross the face of distant stars, able to feel the tug of gravity and also the tug of curiosity, to want to know what's out there, what it means, what it says about us. So much of what we see is the product of physical laws acting without agenda. Gravity doesn't care if it creates a breathtaking ring system around Saturn. Thermodynamics has no preference for the radiance of starlight. The rules of physics are indifferent, and yet they build cathedrals. They construct spiral arms and elliptical orbits and oceans that reflect the moon. They give you comets with tails like silken threads and planets that align in slow, poetic rhythms. They give you eclipses. They give you seasons. They give you the precision of orbital mechanics and the wild unpredictability of a shooting star. Somewhere along the way, beauty slipped in, not by plan, not by force, but by permission. The kind granted only by a universe too vast to micromanage and too elegant to resist surprise. It's tempting to ask why. Why did everything line up just right? Why should hydrogen organize itself into stars, and stars explode into elements, and elements arrange themselves into memory, into biology, into thought? But the stars don't answer. They never have. They only show you what is, and what is enough. So you lie beneath the sky, watching what looks like a pattern. Maybe it is, maybe it isn't. Maybe the moon only looks like it belongs with the sun. Maybe the galaxy only feels like home because it's the one we know. Maybe every alignment we treasure is just what happened to happen. But maybe, just maybe, the accidents are the point. And maybe the fact that you're here to notice them is the biggest coincidence of all. The night sky feels like something above you, distant, untouchable, out there. A ceiling of scattered light stretched over the world like a silent cathedral. It's easy to forget that what you're seeing is not separate from you, that it's not just a show or a painting or a stage set for dreams. It's your origin, your story, not metaphorically, not poetically, but literally, atom by atom. The oxygen in your lungs, the calcium in your bones, the iron pulsing through your blood. None of it started here. None of it was born on Earth. Every one of those elements was forged in stars, not just any stars, but stars that lived entire lives before this world ever cooled. Stars that burned for millions or billions of years and ended in cataclysm. Some collapsed quietly, shrinking into dense white dwarfs. Others exploded in flashes of light that crossed galaxies. Supernovae, the universe's most dramatic exhalations. From those blasts came the heavy elements: carbon, nitrogen, iron, phosphorus, magnesium. All the pieces required to build a planet, a biosphere, a body. When those stars died, they flung their contents into the void. Clouds of dust and gas traveled light years, drifting slowly, pulled into new orbits, new patterns. Gravity worked patiently, pressing and stirring, folding space into denser shapes. New stars were born from old remains, and around those stars, debris coalesced again. Planetary systems emerged, some unstable, some barren, some rich in raw potential. And one of those systems, around a modest yellow star on the edge of a spiral galaxy, happened to include a small, rocky world with just the right ingredients, just the right distance, just the right spin. That's where you come in. Not just as a human, not just as a species, but as matter, recycled, reborn, reassembled from the scattered remnants of ancient stars. The iron in your blood is billions of years old. It watched galaxies form. It rode waves of interstellar dust. It didn't begin with you, and it won't end with you. You are a moment in its journey, a brief, extraordinary chapter in an otherwise quiet story of atoms moving through time. And that's the part that's hardest to hold, because when we say, "You are made of stardust," it sounds like poetry. It sounds like the kind of thing someone says to comfort you, or to make the night feel magical. But it's not just pretty language. It's a fact of physics, of chemistry, of astronomy. You are not beneath the cosmos. You are within it, part of it, made by it. When you lie under the stars and feel small, you're not seeing something bigger than you. You're seeing your family. You're seeing your birthplace. You're seeing the atoms that once were you, and will be you again, and will be someone else someday. When your body returns to the Earth, and the Earth continues its orbit, and the sun eventually swells and fades, the matter that is you will not vanish. It will scatter, drift, join the interstellar medium, and maybe, someday, help build something new. You are temporary, yes, but your atoms are not. They are ancient, patient, faithful to no single shape, but always ready to become. They have been lava, ocean, plant, wind, mammal. They have been air and bone and stone. They have been invisible, and they have burned. You are what they are now, but not what they will always be. And knowing that, or holding that knowledge gently, it doesn't need to be frightening. It can be grounding, calming, a soft kind of forever, because the sky isn't only something to watch, it's something to remember, something to feel, something to recognize deep in your chest when you look up and feel an ache you can't quite name. The sky is not foreign, it's home. And when you admire the stars, when you marvel at how long their light has traveled, or how their patterns drift over millennia, or how their collisions spark gold and fire, you're not just observing something beautiful, you're observing your own context, your own structure, your own past. The light that touches your skin tonight left its source before your body even formed, before your parents were born, before your civilization existed. That light has crossed the ocean of space to find you, and your body, this shape you occupy, was once just floating pieces of that same space. It came together in silence, And for this short moment, it sees you are not an outsider looking in. You are the sky, looking at itself. And what a privilege that is, to exist in the middle of this unfolding, this conversation between stars and time, to carry their remnants inside you, to breathe air they made possible, to listen with your eyes as they whisper stories across impossible distances. So lie still. Let your thoughts expand like the night above you. Let your breath match the slow rhythm of orbits and tides. Let yourself be reminded, not of how small you are, but of how vast your story truly is. You are starlight. Become awareness. Dust. Become voice. And the sky remembers.